In this video, we want to learn how to calculate the mean of a set of data if the data is presented in a frequency distribution. So in this example, we have 1,000 IQ scores, and they have been presented in a table. We have IQs, and we have those in groups. So the first group are IQ scores that are 50 to 69, and what we know is the frequency we'll call F. That means how many IQ scores were in that group, and there were 24. Okay, the next group in the frequency distribution would be IQ scores from 70 to 89, and there were 228 in that group. Our next group are the IQ scores of 90 to 109, and there were 490 people in our sample who had IQ scores in that group. Okay, then we have 110 to 129, and here there were 232 people in that group. And the last group, 130 to 149. And there were 26 in that group. So we should have now a total of 1,000 people in our sample. Okay, if we had each one of those individual 1,000 IQ scores, we could add up all of those IQ scores and divide by 1,000 to get the average. But this is how the data has been presented to us. And so what we need to do is come up with a representative number for each group. Since we really don't know of those 24 in the first group what the scores were. We just know they were somewhere between 50 and 69. So what we would do is use what's called a class midpoint. I'll just put midpoint here, but you'll also see it called the class midpoint. And for each class or group, that's point, we will have a IQ score that represents that group. And what we'll do is just take the average of the lowest score in that group plus the highest score in that group divided by 2, and we get 59.5. That's the best we can do because we don't have that individual data. So going through and doing the same thing in all of these, we get the average for each group, or the midpoint for each group. Now I want you to notice a few things about these classes or groups. What we call the width of the class, notice that the difference between 50 and 70 is 20, 70 to 90 is 20, 90 to 110 is 20, 110 to 130 is 20. We could do the same calculation here. The difference is 20, so the class width is 20. We should also see that with the midpoints. 59.5 plus 20 would be 79.5 plus 20 plus 20 plus 20. That should be consistent in a frequency distribution. Okay, now we'll use that representative number for each class and the frequency and calculate the frequency, how many had this IQ score that represents that class. So we just multiply straight across. F is 24 and X is 59.5. This would be our X, the midpoint. That's our representative number IQ score, and we get 1428. Going down our table and filling in this column, 18,126. The next one is 48,755. Then we have 27,724. And finally 3,627. Okay, and now we need the sum of the frequencies times that representative value in each class, and that's just this total, 99,660. Okay, so the average or the mean from this frequency distribution just equals the sum of all the frequencies times their representative value, the midpoint, then divided by the sum of the frequencies. How many people were in the sample? So our total here was 99,660, and that was out of 1,000 people. So we get 99.66. So this is the mean of this frequency distribution. When calculating the mean, we have a round-off rule to use when we get our final result. The round-off rule says use one more decimal than what was used for the original data. So our original data was whole numbers in this case. So one more decimal than the whole number would be 1 decimal. So our final answer for this average or IQ score mean would be 99.7.